that we have been conducting since the lockdown. And in fact, we have been having a series of webinars on various topics of civil engineering. Today, we have a renowned speaker as well as a researcher in concrete technology, Emeritus Professor from IIT Delhi. So before I go to the speaker, let me just give a brief overview of the initiatives that we have been taking in our organization. As all of you are aware, the Ramco Cements Limited, an organization of the Ramco Group, which started its operations in the year 1960s, now presently is manufacturing 12 brands of cements. That is ordinary Portland cement, rapid hardening Portland cement, Portland Pozzolana cement, Portland slag cement, sulfate resistant Portland cement. And within ordinary Portland cement, we are manufacturing 4 brands of cement. So that based on applications, we have specific type of cement. Like say, for example, what we have seen is that in ready-mix concrete units, we have seen that many of them go in for higher slump retention. Now, for fulfilling that higher slump retention, they need a specific type of cement. So we have the Ramco 53 infra grade cement, which we have customized for that application. Then we have the Portland Pozzolana cement, and within PPC we have 4 types of cement. So that there is a specific type of cement which we call the Ramco Supercrete cement, which is specifically meant for concreting, a high rate of gain of compressive strength and low heat of hydration. So that is one aspect that we have been able to fulfill in that. Then we have the Portland slag cement, which is being used mostly in the eastern part of the country, where we have been supplying to some of the project customers. And we have a specific type of cement, the sulfate resistant Portland cement, which is used in places where there is a high percentage of sulfates. Of course, wherever there are chlorides, we must not go in for sulfate resistant Portland cement. So that's why we have customized the cement based on the concrete requirement. So what is important is that we need to understand the requirement of concrete and then specify the type of cement. Like say, for example, the Ramco Superfast, which is a rapid hardening Portland cement, we basically recommend it for precast applications. Wherever hollow blocks, solid blocks are there, that is where we recommend. So that is how we have customized the cement for various applications. And at the same time, we have various products for non-structural applications like plastering, or for that matter, block fix is there, Ramco tile fix is there, which is coming from our dry mix plant at Sri Perambudur. Apart from this, we have a research center at Chennai, the Ramco Research and Development Center, where we are doing number of works on the various blending materials as well as the concrete mix design based on the customer's requirements. Say, for example, there are so many different types of chemical admixtures that are being used across the various places. So what we do is that we check the compatibility of cement with the specific admixture and see whether they are getting the requirements or not. And at the same time, as all of us know, that there are the quality of sand, the quality of aggregates, the source varies from place to place. So what we do is that at the most, we take the samples from the specific sites, do the concrete mix design for our customers, and then give them an optimum concrete mix proportion, which they have to, which they do a trial at site and then adopt the mix design. So that's how we have been collaborating with various professionals to make a good quality concrete. And we have also been associating with various project customers like Lasner Tubro, ITD Cementation, who are doing a lot of concrete works in various exposure conditions. Some of the concrete works are near the marine areas, some of them are multi-storied building. So as you could see, the application is different, the placing is different, the structures are different. So based on that, we also need to customize the concrete as well as cement. So to give more awareness on this particular topic, we have our speaker today. The speaker doesn't need any introduction because he is well known in the area of civil engineering, and there are a number of videos as well as courses that he has uploaded on the websites and Google. If you Google and see also, you'll find there is a number of talks by Dr.B.Bhattacharjee, who is the Emeritus Professor at the Department of Civil Engineering, IIT Delhi. He obtained BTech degree from IIT Kharagpur, MTech and PhD degree from IIT Delhi, and he is nominated Fellow of Indian Association of Structural Engineers and member of several professional bodies. He was involved with academic activities with several international institutions, namely EPFL Switzerland, University of Dundee UK, University of Dresden, Germany, and Catholic University at Leuven, Belgium. He has supervised 172 MTech and 26 PhD theses till date, and he is currently guiding 7 ongoing PhD research projects. He has published more than 180 papers in journal and conferences. He is active in several national committees involving DST, CBRI, NCCBM, Dr. Fixit Laboratory, BAS, etc. A bio-sketch of Professor Bhattacharjee titled A Teacher and a Research Worker under the feature People is available in August 2012 issue of ICJ and also under the title Gems of Structural Engineering in SCFI. A recipient of ICI Lifetime Achievement Award 2012, he acted as member of editorial board of Magazine of Concrete Research and International Journal of 3 Rs. He is a guest editor of ICJ Journal 2015 issue, and as well as in 2019, he was the guest editor. So we have Dr. B. Bhattacharjee, who has taken off time from his busy schedule to speak to all the construction professionals. In fact, 145 participants have logged into this platform, sir, and more of them are logged into Facebook Live. So all the professionals are keen to listen to you, the gems that you have. Based on your experience and research in the area of concrete technology. Over to you, sir, Dr. B. Bhattacharjee. Thank you so much.
Thank you. Thank you. Thank you.
Yes, sir, you are audible, sir.
Yeah. So thank you very much, Mr. Pillai, Ramco, my friend, for inviting me to this program. And essentially to deliver a talk on quality related. So basically what I'll be talking about is the factor affecting quality of concrete. But exactly straightforward, it will come. And it's, it's basically how it factor affecting and how do we do the quality. So basically, some definitions to start with. For example, quality. What is quality? Essentially means meeting requirements. Right. Therefore, quality management. This means part of my slide because this is coming in. So anyway, I think now I'm fine. So this
if you help, you can call. Thank you.
This basically quality management means the mean that is devised, that's the means, that's the way that is devised for, what is this happening later? Yes, fine. So devised for meeting this requirement. And quality control means to know the status vis-a-vis what you have proposed. Assurance, is available to the party, that is the customers. For example, cement industries, Ramco cement, that matter any cement industry, they do have an assurance program because cement is a factory produced material. And same thing should go to concrete action. I'm not talking of assurance today. And audit is an independent inquiry by third party, examine whether quality is being achieved or not. Now people often confuse specifications. Good quality food may mean actually not necessarily the quality, but the food taste itself is good. Common man's way of looking at it. Quality would be related to whatever you have been promised, whether it is given up to the desired taste. But it's not a different material, right? So specification means could be a different material altogether. For example, M50 grade concrete and M40 grade concrete, it's not necessary, it's 50 grade is Better concrete, maybe in some respect, strength respect especially, but quality is independent of that. Quality is independent. Now, what constitutes risk to concrete? Essentially, it comes from lack of information, understanding resources, and lack of in. This may lead to problems from some sources, which I'll talk about, and when it should be addressed. For example, poor details, wrong geometry, wrong stuff. These are not part of my discussion today, but this can come from method statements and material check. So if you address this in method statements and materials check, then raw material will not come in. Environment, design shape. Now these are related to our site. For example, not vibrated properly, poor cover, wrong cover, weak surface, and joint workmanship is not proper. This is at the site. Checklist and also post-pour check. So what is actually important for us is this part today, but not everything I am covering. I am covering only certain things. One very important thing is measurement. For example, cube strength measurement or anything, any measurement for that matter, slump or whatever it is. Well, there's an acceptance zone. We'll come to that later on when we talk of not so much of statistics, but a little of it. So we have an acceptable zone. And anything in between complies. When it is the border, well, it does comply, but in the long run, it may not. This may comply, but might involve extra cost, unnecessary cost. It's too high. But this doesn't comply. So if we're talking of a grade of concrete, then there's a range within which it is acceptable. We'll talk about that. And if it is higher than that, that's not the best thing to do. Because you are expected to deliver something, but you are delivering something higher than that, at a higher level than that, it will cost you. Our objective has to be remaining within this zone as much as possible, right? And there are a certain amount of measurement also is involved. I mean, uncertainty is in measurement. You cannot measure anything precisely. So there is a certain amount of uncertainty. There are uncertainty involved with sampling and testing, and they need to be looked into. We'll see just now. So we have some upper limit and we have some lower limit of, say, strength or the slump or anything of that you concrete. There is an upper limit and lower limit. Below this is not acceptable. Above this, and it is not necessarily material which you have produced is bad, but the measurement method also, is involved. We'll see that in details as we progress. So therefore, quality assurance I have defined earlier. Actually, it is you are assuring your client today too much, but you are assuring them because this is recording ISO 9000, blah, blah, blah. There are so many things. So the person comes to you, for example, Ramco does mixed proportioning for some organization. So they come to the doorstep of Ramco, the reception, And from there onwards, the flow of information, flow of everything, it is recorded. And the customer can verify it at any time. Traceability, what material has gone in, etc., as it comes out. So that's quality assurance. But quality control is related to production or, production process. So I'm not sure whether Ramco has got ready-mix concrete plants. They may be having. But if you have ready-mix concrete plant,
we have got one ready-mix concrete plant there.
Yeah, so that's where it is more important. I mean, assurance is also related to cement or concrete, for example. So ready-mix concrete plant. So somebody comes, I want to buy the concrete, and from there to the end, it has reached to the site at the formwork because RMC finishes there. But if it is further beyond, then actual structure will be the product, and if the customer is satisfied that everything we can, the customer can check and find out and everything has gone okay, that would be assurance project. But control procedure is within your premise itself. Now, it could be precast factory as well, or ready-mix concrete or anything of that kind. This is what is to interest to us. And it has got 3 stages. First stage, we call it forward control. The second stage, we call it immediate control. I'll define them. And third is retrospective control, which is closely related to this, quality monitoring. Because if you monitor, then you can go and, after producing, you monitor it and then control it if there is anything wrong. First step is forward control. So let's look at it. Let us look at it rather than simply stating in this side. Okay, assurance I have already defined, but formal definition is also here. The operation of systems by which the client can be assured that the control is being applied. All other aspects of the complete process from inquiry to delivery to ensure compliance of the product with the specification of the client. That's very important. The specification agreed with the client. It should not be better than that, but should not be lower than the lower limit. And here, the client is assured. Quality control, the operation of the procedures to maintain product quality at the selected level. Quality. Quality at the selected level. Quality at the selected level. So that's my definition. Now, I was talking about forward control. That involves testing all the materials. So let me concentrate to concrete. So I should be testing all the ingredients. Forward control. If the ingredients are not within a range of acceptability or acceptable range, then usually further variation in the product that is concrete. Right? Well defined, much better defined actually for, let's say, cement, which is a factory producer. They have online monitoring system, they would find out, and steel or similar sort of thing. When it comes to concrete, there's a little bit of, it's getting in. And I'm not very sure we are doing very good statistical quality control in this country. System. Quality you might be giving that, but quality control system adopted is not really most scientific or, the best scientific way, I'd say. So we'll discuss and then we'll find it. So first thing is testing materials. This part many people are doing. Many RMC plant does. They will not accept a cement if it is not up to the mark. Then storage is important here. How do you store the cement? even sand in bins, open bins if they are, and if they are in Rajasthan and summer, you have dust coming in, they'll simply contaminate them. Storage should be such its quality or condition completely. Cement obviously is very important because if if it's humid, moisture comes in, things get then damaged and things protect from mixed proportioning, right? Requirement. And so you just can't unlike in many other design, cannot do it. It's not simple algebra or calculation or any mathematics or put it in a software. You have to test it, and that's what Mr. the side. Procedure. So you might give a broad, it has to be tested at the site. As I call it, design really, but material system design, yeah. Today, because concrete is a like it's a cement based composites, so much wider system, not simply one for bag cement and things like that. Far more material system design, ultra high performance. That kind. So system is very the first thing. And if you've done a design well, then it will be. Plant maintenance, that also forms part of the forward control. We'll see that a little bit more. Your mixer machine should be mixing the job properly. That is, doesn't introduce variable in batching plant, calibration, load cells. We'll come to that a little bit more. Part of forward controls, checking your machines, checking your material system that is going on, storing them, checking the material design, doing it properly. Maintenance of production machinery, these are very important. This is a part of forward control. So if I have a ready-mix concrete, it is gate for entry of materials, there should be testing procedure available where it will test the material and allow it to come in. And when it is in, it should be stored appropriately. And all the batching plant, their batching plant, particularly with respect to concrete, load cells, or weight measuring devices, or say dispenser, right? Discharge of water and things like that. That should be calibrated from time to time. Calibration check. Mixing. We'll come to that more. The first, I have left anything else because cement is factory produced. It's to actually make bad cement unless deliberately does or something goes wrong. It's very difficult, perhaps, if I and switchover make a bad cement. It's what you can see in a screen happening to the process and also the aggregate. Yes, they are important and they are checks are important, but if it's manufactured anyway, this will be again under controlled production. In fact, the size and shapes are all controlled. You can check them, but very often what is ignored is water. Problem. You know, some or other, if you have done, rating is not proper, actually the reward will be high in that case, right? And you will possibly waste a lot of is a costly really. The paste and goes high up. The portability is not proper because your aggregate are not right quality. There are durability issues like alkali aggregate. But water is very important because we find water selection in northern India, they introduce long-term durability problems. North Central away from seashore. Yes. But it can be, because you know sodium chloride is one of the abundant material on the earth surface. Central India, Delhi to even Hyderabad, those areas where relatively rainfall is less. If somebody is wrong, this can. So if you level up and down, then of course you test with the tubes. That's their idea. 456 that you can do, and 28 days shall not be. But I'm more worried about the chloride part of it. Lead to because we find northern India, even Bengal, we find people have used chloride-ridden water.
Sorry to interrupt you, sir.
Corrosion in 5 to 7, 10 years of time. Delhi is very rampant. Setting time. Sorry.
Excuse me. Yes, sir. Actually, you are coming broken. I'll be. Hello, can you hear me, sir? Hello, can you hear me, sir? You are coming broken, so I would be muting your video, sir. Yeah. Yeah, sir, you are coming broken because of the bandwidth, and to improve the bandwidth quality, I'll be muting your video, sir. This is just to keep you informed. Thank you, sir.
Okay. Okay.
Hello. Thank you, sir. Thank you. Please continue.
Is it better now?
As you progress, we'll get to know, sir. Because a little extra bandwidth. Thank you.
Of course, you know, this is score. Now, it should be free from chloride. Obviously, carbon dioxide or bicarbonic acid or that's limited, but chloride is one of the major things. That's what we find. So anyway, that's okay. Then coming to batching, this is important. This doesn't exist, but to varieties of sophisticated measuring also important, right? And weight is very important. Gauges, gauges. Waters are usually flow meters. Some cases they might be weight. This calibration. This should be regularly checked with a routine and some specialist checks for weight. You know, if for example, water, let us say, is and you propose is C, W by C to give, but if you have made an error, it will be W plus minus delta W divided by C plus minus delta C, which means that the strength will vary more if it is W plus delta W divided by C minus delta C. The extreme case, you have very high water. If your is proper, beyond tolerances. There are a certain amount of tolerances the codes allow you. Calibrated properly, even if you know. So batching plant calibration is batching very, very important is batch time to time calibration in your mix portion. And IS code gives you batching. I won't go into the detail, but you can look into it. Cement and others, admixtures by volume of weight. So these tolerances are given, so it should be within that tolerance. Even variation. You know, tolerances applied to maximum 30% of the scale capacity divided by weight tolerance as in the table. So it's a guideline. Now, next point, which is very important, is mixing. If your concrete is uniform, it will have variation. Variation depends from proportions, as I said, you know. So if your coarse aggregate, let's say coarse aggregate is C, WC, then you can, tolerances is WC. Similarly, fine aggregate. These are variations. If you do proper weighing, these variations will be less. If your calibration is proper, this will be less. Each one of them is changing the proportion. You can see that. More, this you might add more or less, you just don't know. So your mixed proportion that actually you have designed, there will be a lot of variation about it because of the production process. And therefore, forward control should, look into these issues, check the calibrations regularly, and makes it uniform. So you need to exhibit less variation. There will be variation, nevertheless. That's what I'm highlighting all the time. Higher delta C, higher delta W, errors in cement and water movement will result in higher variation in strength, in all properties, in fact. Forward control. Mixing. This also I want to highlight. Introduce non-uniformity. Supposing you collect samples, fresh concrete samples at different stages. And then check the properties just immediately. So your mixer machine, of course, the bottom opening mixer machine in RMC batching plant. But if it is rotating drum, this sort of rotating drum, not used anymore. In RMC plant, you won't have that. But supposing site mixed concrete in a small batches, what will happen is come in the beginning. You will have paste in the beginning, more paste. So if you see the bottom, more paste. Larger aggregates will come in, and paste will come later. The flowability of larger aggregates is more. In fact, travel more. Large aggregate, AGG. Paste travel less. Put it on a wheelbarrow. If that is occurring here, you'll have more aggregates, stony batch. Itself introduces a variation. Then I was talking about charging and blending. Charging, pre-blending, reburning effect, etc., etc. These are all issues actually. Now, certain guidelines are gives you 1 minute is required for and 0.25 minute is each additional 0.7 meter cube capacity. Okay, guidelines. But my point is, you see, this is the best way rather good dry mixing for a solid components content in the mixer. Is this. Then there is some water is added here. Wet mixing and final water added here. Then mixing period, then discharge period. That's a good kind of a practice. And there must be many revisions beyond this. Batch material except for full amount of water, etc., etc. To flat. I just specifies that minimum. Okay, that's fine. Mixing time may not result in more uniform distribution. Increase in more uniform distribution of hydrogen, and therefore it strength. But if you prolong it, it cannot increase the strength proportionally. It has no benefit. So it's a soft aggregates, there could be any might increase event. So this is what people have seen. So the machine, look at workability of fresh concrete. Density concrete check. How do we do that? We'll just talk about it. Air content, segregate content, and ratio, and cement content. Now, 15% of the discharge. First 15%. Machine is discharging samples, measure their workability. Immediately, of course, wet measure, air content, compressive will require time. Because analysis of fresh concrete, what is done is it is sieved through 4.75 micron sieve, whatever is retained, that's the coarse aggregate content. Wet sieving to 2.36, whatever is the solid particle will be cement or powder. So there are ways. So from first 50% of step find this, and last that is after 85% of discharge, you again find out this problem. So 85% is discharge, And if the variation is not too large, really what happens is, initially there's a tendency to actually discharge or segregate. So more stone space sticks to the surface of the information. Mixes are much less, tilting down mixture is much higher, right? You know, I mean, pen type of mixture with bottom discharges are much less actually. This reduces down, but nevertheless there will be some variations. This mixture machine is made. All 7. And there are criteria for RILEM. It says that, you know, basically performance of variation, which is divided by mean, you know, or S divided by X bar. You have done several tests, find out their mean slump, let us say, standard deviation of the slump from 5-6 tests. And if this ratio is less than 6%, is ordinary. Above 6% is acceptable impact. I mean, it will not be good enough. So this water to powders ratio, this should be less than 6%. If it is less than 3%, standard deviation, variations are less, then you call it others one. You know, so that's RILEM criteria. Standard, all 7 are to be tested and the values are given. For example, compressor not vary more than 1 MP or something, plus minus 1 MP or some such thing. No, it is given. So these are given. Right? What we find is, if you increase the mix, strength increases and variance, which is actually standard deviation related to variation. So optimal mixing time concepts and doing practical and batching plant, that will be very good work done. But that would be very good work actually. Control. You know, you test material mixing, involve batching, mixing machine, check their performance from time to time. And that's possible, not submission. Just replicate. Ready mixed concrete plant. Site mixed concrete cannot be as good quality-wise. Quality control cannot be as good. In fact, many of the developed countries use about 7% of their cement for RMC route. In India, I'm not very sure, it was about 5-6%, more than that. But in it may not have picked the action has also picked up 7%, let's say, mechanized food, but otherwise it is still quite a bit of non-mechanized. And there these problems can come very regularly. Where there nobody bothers. But RMC plant can be used. Immediate control. In the process that we have talked about the factors which are affecting, right? The weighing is correct, but the computer system you have already, given the input, it will work. Of aggregate, their immediate control during the production process. This was all forward control was all before production. Before immediate control during production. There's not much. and then adjust the cement plant. Even they get the uniformity. Your machine is performing percent of the dispatch. Take even from the truck, you can do that. %, after it's higher because you get stuck in traffic jam, or number of revolutions are quite codes. Say we can't have more than 300 rotation at agitating speed. But in India, of course, it goes. But whatever it is, you can take a sample after such agitation remaining uniform. When in your batching discharge, you can mix discharge. This is a retrospective monitoring. Now, I was already saying that mix not mathematical, not very simple. How sigma, if I call it strength, or F, I think, yeah, no. F cube strength, water cement ratio, we know, etc. But this function is not known. It is not known. You go to any code, functioning, you'll find several water cement. Because it's not universal. I can't an equation. Slump is function paste content, volume of paste, and the water content in the paste itself, water in the paste, or the system admixture content. But again, I don't have. So I have already a property for that matter immediately which I can test. I have to actually do a test. Slump or whatever it is, slump is generally setting character. To do it. There's no other way. So therefore, this is proportioning is not mathematical. Not math. And that's why there are n number of methods. A RMC plant can develop its own method suiting to yes. Is again something more than that. What is the problem? This might go on changing. For example, let us say XYZ takes a Ramco mix. After 1 month, because Ramco would have taken a small amount of sample, right? Their own cement, let us say, we are controlling good, but still there will be variation. Some other aggregate, etc., etc. There are several of the truck and things like that. So this will not be valid. It has to be monitored continuously. It has to be monitored continuously. This is not like many other production methods. too many ingredients you are producing, so it has to be monitored. So monitoring is very, very important. And to my understanding, very few people are doing it in this country in a scientific manner. So you have to have a continuous check, corrective measures, adjustment, and statistical concepts of you find out mean, standard deviation, and you have to have an accelerate. Accelerated much necessary because you cannot wait for 28 days test to modify your mix. Now I'll come quality of concrete is measured. Characteristics feature like slump I was mentioning, and for fresh and hardened state of the concrete, certain properties you should measure. Most common 28 days composition to judge the quality of concrete. Concentrate on than anything else. You can't have it and all the products are completely alike. Even if you steel wire, let us say, you're cutting it by laser or cut it by a chisel. Variation. Laser, but it cannot be exactly same. Say I wanted to get it 100 millimeter, I'll get it 1000 plus. More fraction with laser cut, and in case I might get discount, etc., etc., several things. So no method can be absolutely perfect. And concrete is, of course, there are two things. So there are a large number of small uncontrolled factors which are responsible for variation from one lot to other, and they are actually regarded as chance variation. So purpose control is variation. So now you can see if your plant is being within a range, it's not varying too much. Not add to the concrete mix proportion because water, much higher water, less aggregate the cement quality nearly same. So minimize this. So properties, variation of properties we control by tests, and we said forward control, proportion by control by variation of processes are all forward control. Quality, also cube compaction quality, sample compaction quality, many such factors. Now strength test is an important, which I didn't cover so far. See, strength as we test, our rate of loading is very important. And this I find that many test laboratories don't bother. That's why I've kept it here. So higher loading rate is higher strength. Now IS code has standardized it to 14 MPa per minute. So rate of load, strain rate as you increase, measures static strength, measure strength, or it increases. So basically this is rate of loading. This is from an old book. So pound per second was the, you find that strength increases. Because crack propagation strength time. So these are the issues. Then moisture condition. So should be the condition as suggested in the code. Now, can variation, sampling error. First of all, you make sample, some failure and remix cube. They can add left hand side is minus, they increase the strength, right hand side is sampling error, both plus and minus. Faulty. So there are several things machines that test can introduce simply variation. It can have lateral distortion, can create problem. Not going too much. But if the cube is like you export some bend, not exactly desirable. So normal cube that should have been something like this, but you get something of this kind. These are should be checked. Their machine should be checked. So this is normal. C is excessive. And displacement versus strength curves shown, and so on. The crack, horizontal crack coming, that is tension, right? There's a tension along this direction, that means there's been kind of a bending, and so on. Concave surfaces, right? And convex surfaces. If your mold is not proper, then sampling is 3 specimens in a sample. I don't think I'll go because I think the time is also a factor. You'll get bored if I talk too much. So this space, depending upon volume of ore, and cube strength varies in this. For example, if I have a complete cube, we thought we should be making it for 55, and then I go on to the test. These are the number of compositions. There's a number of samples or specimen showing strength, for example, number of specimens showing strength from 50 to 50, 32, 55 to 54, 20. Now, there's a reason, actually. This is what is called, why there are too many factors affecting the random variable. Here, random variable is compressive strength, measured compressive strength. And, when this is how it. So when there are many factors, as I said, fraction variation can vary in this way. And this can be actually normalized such that the area under the curve is 100%. If you divide by total number of samples, each will be a fraction, and sum of this fraction will be equal to 1. You can approximate this into a kind of curve, and average represents mean, standard deviation is a spread, right? And it has been seen as a rule, 6 standard deviation. This is 3 standard deviation, this is 6 standard deviation, because these are all relative measures. And for your characteristic strengths, this can be formed in this manner. If you have some question, I'll answer there. And your characters lies here. Your 5% sample will be 5% sample will be failing, and 95% sample will be failing. Just a minute. Key.
Yes, please.
Okay, so that's FCK plus 0.65 sigma, we know is the mean. So anyway, this is known to you, maybe. But if I test more number of samples, then I get this sort of curve. I think I'm running out of time, so I'll have to see that how I do. So sampling, distribution of mean, because this is relevant to acceptance criteria. I don't think I'll go into this now. Now, this is your monitoring. If you have data testing available, you might find the strength varies in this manner. And if it goes continuous, which means that you have designed your system of one. Control charts gives you, it should be between upper and lower control limit. Okay, so I was told that time is not a constraint. So I'm quite happy to go back to this because I'd like to explain this. So this is 5% of the samples. Supposing I test 100 samples, FCK will correspond to 5 samples should be failing. So the strength, 95% of the samples, or 95 samples, percent of the samples should show more strength than this. That's what we call it FCK. And this is from law of statistics, because the mean is higher. And FCK plus 1.65 sigma. So some this mean you can find out, and standard deviation I can find out this manner. And this standard deviation I can find out using through this calculation. In this I think I'll leave mathematics part. But if I try to take a samples out from this, take some samples, random samples, let's say n number of such samples, and then find their mean. Now I can take a sample, from here, another sample from there, another sample from there, I have taken 4 of them. So their mean will be somewhere there. Let's use another color, 10 of them, 1, 2, 3. The chance of getting something there is also 10 of them. I might find mean closer to this. So if I take some samples from this, 10 cubes, find out the mean of the means. Mean of this samples, 10 samples, they will be closer to, if infinite number of samples, find out the mean, this several times repeats it, it will be, mean of those means will come. Am I clear? Let me make it clear again, because this is an important statistical issue. I'm taking samples, random samples from here, n numbers. Finding out their mean, find out mean. This I repeat times. So I'll have m means. Now this m means I can plot a histogram. M means a histogram. This is called of sampling mean. So m mean will be. Now, if the n size is large, if it's infinite, then I get all. If n is equals to 1, it will coincide with this. So this distribution of the mean, sampling mean of the mean, distribution of sampling means mean of n samples. That's what we call distribution of sampling. So if I take 4 random samples, that's what in your acceptance criteria you'll find it says take 4 consecutive non-overlapping samples and all that. That's actually what it's trying to do. Mean of those 4 mean it's trying to find out. We'll come back to this again. So various components actually adds to the standard deviation. This is the way can be, which I just mentioned. Control charts are something of this kind. This record you should maintain, monitoring. So this is date-wise. Let's say March 30th March, 4th April, 6th April, week-wise. It's showing every day's record of a particular concrete. And this you can, there's a control limit. Now what will be upper control limit? perhaps I have an equation. If I don't have, I'll just give it. Yes, it's there. Target mean strength is 50 MPa. There are variations in this. An upper control limit, it would be target mean strength minus 3 times the target standard deviation. Because that's the variation we have seen. That's the variation we have seen. That's the variation we have seen. 3 times standard deviation. And lower control limit will be target mean minus 3 times standard deviation. Target mean minus, this is upper control limit, 3 times the target, but warning is this, because that's uneconomic. You should not go, and lower warning line is 2 times target, lower control limit. So if it is below this, it's not actually acceptable. It's not the same concrete, something is wrong. So this is how we monitor the same way. That's called a shoot, right? Strength monitor, date of casting. And this you better do through an accelerator. Well, there are simple way of doing this also by what's called Q-sum method. Data and define the range. What is the range? I'll come back to this. Maybe there is something more. Charts are there. Just let me go back to, and I'll come back again. Yeah, this is what I am doing. Accelerated test is important. This is from a British code, actually, of those kind. So it should be currently BSEN, and it's a right, and do an accelerated cube strength. Now, strength, normal 20-day strength, you can actually, or 7-day strength, your own correlation. You have to develop your own correlation. So this I was saying that, so this could be, not be 2 days, maybe within 3 days, you get this. Control you want to do, whatever. Now, I can take 2 data. If I take 2 data, range is defined. Rate is defined. Some value minus will be the rate. Because maximum values, for example, in this case, in this case, oh, yeah, in this is the maximum value, this is the minimum value. So range is this, but range for 2 data is simply the difference between these 2, right? So range is defined in this manner, and range can be related to mean as well as standard deviation. Range can be related to mean as well as standard deviation. Range can be related to mean as well as standard deviation, right? So range can be related to standard deviation. For example, to mean range is equal to K1 into standard deviation, mean range, and standard deviation of the range is again also related, but this I am not interested at the moment. So if I find out range from 2 data multiplied by 1.128, this standard deviation I can estimate from there. For example, range divided by 1.128 will give me standard deviation. I can estimate. This is an estimate, right? Okay, so that's okay, because if I have 6 data, large number of data, then we have seen that 3 sigma, 3 standard deviation plus and minus 3 standard deviation, 6 standard deviation is equals to the range. Let me go back again to this. This I said that was 6 standard deviation, 6 standard deviation, 6 standard deviation, 6, 3 this side, 3. So for large data, it is 6. For 2 data, that's how it is. We'll come back to make them right. So that's what it is. So for each standard deviation, which I have decided earlier from my past data, target mean range will be this, so that I can follow this range and see whether this range is what I wanted. For example, if I had a standard deviation of 4.5, I would expect range to be 5. So previous day's data, today's data, that from that I can. So short chart for range also I can. That means I can monitor my standard deviation also. Right? What is my target range? Which will be 1.128 into standard deviation, and mean, and its variation we can monitor. So we can monitor both mean as well as standard deviation using this chart, and rate-wise we can do it. But the limitations, the charts have some limitations. 28 days strength, this could be predicted strength, as I said, through accelerated test, so that I can take action and verify this later on. The limitations are, these limitations are, give me any other information that I am within the range or not. If going beyond some days, since when is it a trend or a random variation, that I can't. So there's something called Q-sum method, cumulative sum method. And many codes have this actually. BSEN do have this kind of a quality control system, both for mean as well as standard deviation. So for example, if I have results numbers, and these are my strength values, this would be accelerated strength. Again, I'm saying, so they don't have to wait for 28 days. Now your target strength was 40. So today, first result you found, so the deviation from the target is +4, deviation from the target is -2, and cumulative sum of this is on this way. So 4 minus 2 is +2, and again there is +5 makes it 7, +8 -4, and so on. And then you can plot this Q sum against this result, which will be something like, so accelerated test, I was just saying 35, they have 3 regimes, and it has to be specific to yours. It is not a correlation, is not same. So you can choose any one of them from any code, or you can develop your own and develop your correlation yourself. So the time frame is also going 20 degree, cast seal, keep it in 20 degree for 1.5 hours, for and place water at 20 degree, heat at temperature, etc., etc. So there's a accelerated test regime, right? So you can do the accelerated test, then you get the answer pretty fast. Then you can verify this correlation later on. If it is changing, then you have to read, look, calculate your data. But this is all possible. So this is the Q-sum plot for a mean for the same data, the Q-sum plot for the mean. So this, if I plot it here, Q-sum values as the result number. Now, if you see, this is going downward. It's going downward. It's going downward. You see, going downward. Even from this data, it was all negative. It should actually swinging between 0, plus minus something. 0, if it goes like this, your things are under control. If it is going like this, and then come back, and then going, it's under your control. But when it continuously goes down, there's something wrong. You're not giving good strength. If it is continuous, it continuously goes up, your system is over-designed. A to B is continuously going down. So, gone wrong since A. So you get more information. It's not simply telling you that whether you have done right or wrong, things could have gone wrong. To do that chart is called a V mask. This statistical design already proven, so you don't have to really go into its theory, but if you want to, you can go to. This value is 8.1 sigma. The slope is sigma by 6 for mean, when you are doing for mean. And this you can put it on a tracing paper, or you can make this in Excel sheet today and put it onto your last data. Put it onto your last data, this mask. This is sigma by 6 and this is 8.1 sigma. And if this point is going beyond this, for example, if when I put it here, the same thing, it would not have gone out. It would have been inside. But today I put it in here on the 18th result. 17th result I put in, everything is okay. 18th result, when I have put in, I find that one of the point goes out. Point C is out, which means that systematic reduction. It's not random, it will not come back. You have to make it to come. So this Q-sum technique can be used to actually identify whether things are going bad or you are designing. And once you have found that it's gone out of the mask, you redesign them, you change the mixed proportion. So you see, this is to be done at the site. It cannot be done at IT laboratory, which is normally done by most of the contractors. Because the government organization insists the mixed proportioning should be done at IITs. I mean, some private bodies might take from Ramco, but PWD will insist that it should be done in IITs and IITs or blah, blah, whatever it is. I think it's a bad practice. Even if it is done at Ramco, it cannot be eternal. It has to be checked from time to time because there are so many variable factors. Once you found that something has gone wrong, monitored, you restart it again. Right? And check it again. This can be done. This is, I mean, every result you can check. It's very easy jobs. A program for this. Program, but one can do it. And this will tell you, this will ensure that you are not wasting your cement, sustainable, not wasting your cement, and not failing if you are selling ready-mix concrete. Right? So Q-sum also similarly can be done. So range is difference between these two is 6, and my target range for 4.5 as a standard is find out. You can plot exactly the same thing. So is your standard deviation going away? That you can find. But here the B mask is somewhat different. That's 8.5 sigma by 10. There's a basis for. So mathematical formulation, if somebody has a question, I can answer this. Write an algorithm for this. Proportion you have to change. Check the correlation. If the correlation is while monitoring, re-establish the correlation, change your results, change the mix, so many things. It can be done continuously, it's not a big deal. Right? So actually, how much strength in chest is because I'll just see because from here I know how many results are there. How many results? That many results, right? That many results are there. Okay, and 8.1 plus sigma by 6 into this length. So this is divided by the total number of results will give me strength reduction that is happening. Strength reduction that's happening. Strength reduction that's happening. So that's so it will show you the delta sigma strength. Change in strength is one can find out delta Fm di plus n into g divided by n. So average change in strength one can find out, and this is the formula, and you redo the mixed proportion. So delta sigma is this, and you redesign the mixed proportion. Just 1 minute, I'll think. Sorry for the interruption. Okay, so that's how we can actually find out, redesign the mix. If you have some questions, I'll definitely answer. N is called run length. That is this. This is called run length. This is available in a British code. This is available in British code and many other codes. This is called run length. N. 8.1 sigma, plus sigma by 6 into N divided by N is a strength change per day. 1. There's the formula. There's the formula. I think yeah. That's the formula. That's the strength change. And this is the strength for mean, and this for standard deviation. So you have to redesign the every time. And to do that, any mix design procedure you can use. I've just taken an example of DOE curve. The curve has actually changed because you are finding that delta FM actually should have been, but now it has become FM minus delta. Your water cement ratio is this, and for this FM minus delta FM, which is the curve you can go. Your FM value, for your FM value, so this is for your FM value, you have to change the water cement ratio. So this is your curve. And now actually your FM is somewhere there. You have to use lower water cement ratio. You are getting 30 strength, let us say, for the given water cement ratio. This is 30 is FM minus delta FM. So actually this is your curve. For your FM value is somewhere there, 33 or something. You have to reduce down the water cement ratio and reproportion the mix. So that's how it is to be done. I don't think I'll go into this equation. This is what I developed, correlation of this British available. We did this for some case. That's how we took in Delhi. And for mean, we find that actually it was over designed. For this was some plot for mean, in some other case, it's over designed. 0 and it is continuously going up, they are not bothered. It took some long back, 2004. This is available in a paper. Control chart for mean. So control chart for mean also we were plotting, but all the time it was above the target mean. So that's what it is. So we have defined objectively what is quality. We have defined the production, etc., testing, whole process, etc. We talked about. Now, if you look at acceptance, it says mean of group of 4 non-overlapping consecutive samples. That's statement saying random. Time to random. You can't choose it yourself. So non-overlapping means you have not used it. Consecutive samples for 4 samples. So mean of 4 samples should be maximum of FCK plus 0.825 or FCK plus 3 for all grades. Now, what is this? You see, FCK plus 1.65 sigma is the target mean. Oh, let me just clean it up. This is the target mean. Now, if you have taken 4 samples, this can have a variation, and the minimum it will have is 1.64 under root 4, because 4 samples and you are finding their mean. So this is sigma by 2. They have deliberately taken 4. Otherwise, this will be, your mean as you are obtaining. Minimum mean you should get is mean should be FM mean that you are getting should be greater than FCK plus 1.65 sigma by 2, and here sigma, so 1.65 by 2 sigma, which is FCK 0.4. It comes like this. If or all grades, they are put in this manner. That's for, and it also says for individual test result, it should be greater than FCT minus 3 because 5% is covered by this. Our minimum value cannot be lower, right? 1.35 sigma, because I know 3 sigma was there. Remember 3 sigma was there, 3s or 3.65, 3 minus 1.65 would be 3.5, 3, and 2 minus that concrete. So you can't expect. Characteristics card, OC card for ready mixed concrete, because 5% is the acceptance by the client. But there's a probability that it will be less than 5%, although you have actually given 5%, because 5% probability is still there. And there's something called operation characteristic card, which should ideally be, if anything, if the defective is less than 5%, it should be rejected. So probability of rejection 100%. And if it is no defective is less than, if it is less than 5%, if it is more than 5%, it should be, if it is less than 5%, 100% accepted. If it is less than 5%, it should be rejected. So this is it should be rejection, 100% rejection. But actually it is found something like this. Let me repeat it. If the more defective is less than 5%, it should be 100% accepted. If defective is more than 5%, 100% rejected. That actually should be ideal condition. But it can so happen that you have actually produced less than 5% defective, but still there's a probability of rejection, because this is the probability of rejection. This is the probability of acceptance. Below this is probability of acceptance. Because actual operating curve is something like this. And this also comes from statistics. This is called hypergeometric distribution. I'm not going into it. So some of the ready-mix concrete plan will try to make it FM plus FCK plus 2 sigma to reduce down what is called producer's risk. This part is called consumer's risk. Even though it is bad, you have still accepted. Even though you have a 70% chance, even though it's defective. In structure, of course, strength varies. If you have M35 grade of concrete, mean strength will be something like this in cube test. But in top of structure column, you will find actually this if you do code test. Slab, beam. Don't worry. This is taken care of in design by a multiplying factor 0.67. Right? So nothing to worry about it. Thank you very much. I'd like to answer some of those questions which will be there. There's a difficulty, of course, online stuff, face-to-face is much better. Thank you very much. If you have some questions.
Thank you so much, sir. It was a good presentation. In fact, you had covered about a lot of practical aspect on how, even though mixed design is done in a laboratory, still the trial has to be done at site on a regular basis. That was a very important point. I think many of them, some of the small sites take it for granted, and the mixed proportion is not, mixed design is not done on a regular, trials are not done at a regular basis at the site itself. One question is there from Dr. S.P. Anchuri. Can I have the question, sir? Bhattacharjee, is it up?
Yeah, you can have the question. Yeah, my video is on. Yes.
What he's saying is that he says that QC of RMC is found challenging in captive plants because they say that we are using branded cement, good aggregates. As it's in-house production, the errors are neglected until major issue arises. Any suggestions for captive RMC plants? No, because
L&T has got his own plant, it's supplying concrete to his own site. What is the problem?
Correct. Okay.
No, I haven't understood the question. He can repeat the question.
The question is, QC of RMC is found challenging in captive plants. They say we are using branded cement, good aggregates. As it's in-house production, the errors are neglected until major issue arises. Any suggestions?
That's right. QC, not QSUM. Acha, quality control. No, you do this strategy monitoring. I've applied this for last maybe 15, 20 years. I have at least 2 articles in Indian Concrete Journal, and some or other the government department is a culprit. Let you take it, openly I'm saying. Many of my colleagues actually opposes me because they use mixed design consultancies, which are ridiculous, should not be done at IIT. We are not meant for that. It's not changing at all. So mixed design should be checked, monitored continuously at the site itself. Do it at the site in that captive plant. And it's such a simple job that, it's a tables and keep the data continuously. Get your mixes, monitor it time to time, involve you or whoever,
True.
Diploma in civil engineering, not even degree. Degree is good, he will even understand the statistics. Or even if he has got a little bit of mental intention, diploma holder can. It is not a problem. BSc people can understand. Today you study them. So it's not a big challenge at all. It's not a rocket science. Only thing, we don't have the attitude to do it. Do a QSUM, do a monitoring. Without traveling, email, I can help you out. But if you want in situ traveling and things like that, that will take longer time. Then it will be a consultancy charge.
Correct.
I have no problem, but this not a problem at all. Nobody is doing it in this country. Long back with one of our students, actually, he took my in course. I was teaching this somewhere around 2000. Anuj Maheshwari, he's with Reliance now, I think. Earlier with Ultratech. He's a very brilliant guy. And he was managing Ultratech. I told him, he said, sir, I'm test everything, materials and all. But we do any monitoring. Now, why aren't you doing monitoring? In front of you in IJ, you don't want to get into this. You do an accelerated testing, monitor it, you will not have the problem later on. That's my message.
But certification is also not mandatory, sir, in captive power plant.
Certification is another. Certification is a third-party certification. That's between.
Okay.
Right? It's a question of trustworthiness or in contractual system.
True.
But basically, if somebody wants to implement engineering, quality control, it's not a difficult job at all.
So thank you so much, sir. I think there is some bandwidth issue from your side now. Yeah. Now it's okay. Yeah. So thank you so much, sir, for having spent almost 1.5 hours with all the professionals, and you have touched upon very practical issues, very simple, but very often neglected, because that is what we can say. Mostly it is being neglected. And as you rightly said, it is a matter of attitude. Quality is a matter of attitude more than anything else. It's not a rocket science. So,
not at all.
Yeah.
Side effect, the contract side. Ramco, CBRI, then they can take.
Correct.
But get it done in the site. Nowhere in the world this is done. But we don't trust ourselves. Very unfortunate part of it. That's what it is.
Okay, sir. Thank you so much. Yeah.
Thank you.
Sure. thank you so much, sir, for having joined here. And tomorrow, again, we have 2 webinars on green building. So I request all the professionals to join. And on behalf of Ramco Cements and behalf of all the professionals, let me once again thank Dr. Bhattacharjee sir for sharing his experience. Thank you so much, sir. So we sign off from today's webinar. Thank you.